configuring devices. In this nugget, we talk about configuring devices, and we talk about, first of all, how to work with Device Manager. Now, Device Manager alone will address most of the exam objectives relating to updating, disabling, and uninstalling drivers, conflicts between drivers, which are actually resource conflicts, and driver settings. So most of those things are really addressed with this, as well as resolving problems with devices, device drivers. We also take a look at signed drivers, why they're signed. What's the advantage of signed drivers? That sort of thing. And then we also take a look at troubleshooting devices as well. And even though that's not really an exam objective specifically, it's very useful to know as a Windows administrator. Years ago, when Windows 95 was still in beta, which means, of course, that it's in the testing phases, Bill Gates decided to show a preview of Windows 95. And, of course, Bill Gates is the founder of Microsoft. So he got up in front of a huge audience at some conference. I think it might have been Comdex, which they don't have anymore, but that used to be the big conference for everybody to go to. Anyway, he demonstrated Windows 95 by plugging in, I think it was a USB device of some type, and what would you know but that all of a sudden, instead of showing off this great plug-and-play feature, the machine blue-screened him right there in front of everybody. It was quite embarrassing for Microsoft, and I'm sure that somebody lost their jobs over that. But it was kind of a harbinger of how plug-and-play was going to go for the first few years, because it promised a great deal of convenience for administrators and simplicity, so that all you would have to do is to plug in a device, the appropriate drivers would be detected and installed, and then you could just use the device, and there was really nothing else to it. At least that was the way it was supposed to be. Well, it didn't really work out that way in early days of Windows, especially because of legacy devices that were not compatible with plug-and-play. And we used to even make fun of the name. We used to call it not plug-and-play, but plug-and-pray, because you would just pray that it would work properly. And I've got to tell you, people that are probably the best at troubleshooting devices and drivers are those who have had to slog through those old days, like I did, back when Windows 95 and Windows 98 came out, and we had to mix and match various types of hardware. Some was plug-and-play and some wasn't. And that was real troubleshooting for hardware back in the day. Nowadays, quite fortunately, it really mostly works just fine. It's been a long time. It's been years since I've even had a true troubleshooting issue relating to drivers or devices themselves. Sometimes I still have driver issues, but those are generally relatively easy to resolve now, and I'm going to talk to you about troubleshooting some of those items. Well, hopefully we don't have the same kinds of troubles that Bill Gates experienced, although all of us are going to experience those things from time to time. But if you do have to troubleshoot a device, chances are you're going to have to use Device Manager to do it. Now, there are other more elaborate ways of doing this and command line ways of fiddling around with all these things and working with the registry and stuff. But in reality, Device Manager is probably the most efficient and effective tool to use to work with devices. Now, first of all, let's understand how we actually open up Device Manager. This can be done a number of different ways. You could go to Control Panel, and in Control Panel, you can go to Hardware and Sound, and then in Hardware and Sound, you would simply go to the Device Manager item. I see we're off the screen there, so let me drag the window back down here a little bit. You just simply go here to Device Manager, and you have to be an administrator in order to open this up. I'm logged on as an administrative account, and so that's why it simply popped right up. Other ways of being able to do that is you could also go to a command line. So I could just do a start and a run here, for example. Actually, let me go here. I could click on start and run right here, and I could do a CMD, and then I could type in devmgmt.msc. Or I could have just done that directly from the search line, but either way, I'll press enter here, and again, if I'm an administrator, then it will open up Device Manager for me. And then finally, and this is the way that I most frequently do it, is I use computer management. Now, you can do that by typing compmgmt.msc, or you could right-click on Computer here and also choose Manage, and they both do the same thing. They will open up the Computer Management console, which I can see here has opened up in the background. And the reason why I use this one mostly is because if I'm going to do anything, well, a lot of these things are already included in what I might need, and there's Device Manager right there, and so I can just continue to work with it from this perspective. So what is Device Manager useful for? Well, it's useful for viewing your various devices. Now, where's my whiteboard? There it is. It's useful for viewing your devices. And you can do this in a number of different ways. So, for example, let's take a look at all the different views that we can work with. Number one, the default view that we see right here, and you can see this by right-clicking here and choosing View, is the devices by type. So you can see that it's divided them up into a number of different categories. For example, disk drives. Any disk drives, if I have more than one, would show up here. If I had more than one network adapter, those would show up here as well. If I have more than one processor, you can see that I have a quad-core processor. So those all appear right here as well. This is actually, by the way, the reason why we see 4 Xeon processors, which is a little bit uncharacteristic of a desktop computer, is that this is actually a virtual machine that I'm accessing via remote desktop, and it's running through Hyper-V over on a Windows Server 2008 data center server. So that's why it's got quad-core Xeon processors in it. But that's neither good or bad. That's just a thing I would note for you there. And then we also have any other kinds of devices that we might want to explore and take a look at here. This is how we would do that. Also, you can change the view here as well. So I could say devices by connection instead, and then it would show me different devices that are connected to various parts of the motherboard. So for example, if I wanted to see any ACPI types of devices here, well, they would all be included in this. ACPI is the Advanced Configuration Power Interface, and although it makes it sound as if it has something to do with sleep or hibernate or something like that, it's really a larger standard than that encompasses virtually all of what Plug and Play is really comprised of right now. So it's a big part of Plug and Play and a big part of resource management, which we'll show you here just shortly here. So you can look at it in this kind of a sense here as well. And then another way you could look at these devices is you could look at resources by type. This is one of the most useful views that you can use if you're actually having trouble with a device conflict or a driver conflict. Now, when we say driver conflict, and that's the way it's stated, I think, in the exam objectives, is conflict between drivers, there's really no such thing in most cases. Really, it's going to be a conflict between the resources that a driver allocates to a device. Okay. So anyway, here we have direct memory access. To what devices are using my direct memory accesses? What I/O devices, rather I/O resources, do I have here? Okay, this is the input/output address for various devices. The interrupt requests that I might have, the memory addresses that certain devices use. Some devices have a certain portion of memory that they kind of lock down for their own use, and they don't release that memory or use it for any other purpose. And so it's a reserved memory for these particular devices. That's what that would be. And then the interrupt request you can see here as well. Now let me just take a quick note here to talk about ACPI again. Remember I mentioned earlier that it's a lot more to do than just the power management. What it also has to do with is how resources are allocated. In the old days, we had 16 interrupt requests, 0 through 15. And very often you might have a mouse attached to a serial port that used one interrupt request. And then maybe you would install a new printer that was attached on another serial port. And then as soon as you would try to use your printer, the mouse would stop working, or vice versa. Well, that's because they were very often contending for the exact same interrupt request, and only one device can use that interrupt request at the same time. Interrupt requests, by the way, are simply that. They interrupt the processor requesting attention, saying, hey, pay attention to me, I need some CPU time. That's exactly what they do. Well, now notice this. If we go down through this, first of all, we've got a whole lot more than just 16 interrupt requests. And I don't really know if I have any on this computer, but very often you'll see that you'll have interrupt requests that are shared by more than one device. We never used to be able to do this. Actually, I guess I don't have any here. We never used to be able to do this, but because of ACPI, number one, we get a great deal more interrupt requests than we ever had before, more than we'll ever use. And then we also have the ability to do interrupt request sharing. Now, do you need to memorize any of that for the exam objectives for the 70-680? No, you don't. But as a practical administrative note, that is something that has greatly improved life for administrators in recent years. If you're like me and you were first troubleshooting Windows back with Plug and Play in Windows 95 and Windows 98 days, we very often would have legacy devices that were not able to take advantage of that expanded interrupt request table. And so as a result, we had to use the old-fashioned method for assigning interrupt requests. Sometimes you'd have to move a jumper on the actual device itself, like a modem comes to mind for this. And by moving the jumper from one set of jumpers to the next, you would specify a different set of resources or a different interrupt request that it would use. And so we used to have to do all that the old-fashioned way, and a lot of trial and error, and it was very, very frustrating many times. And then going back here to looking at devices by type, let me also point out that you can go to View here and choose Show Hidden Devices. Now these would be a couple of different types of devices. Number one would be a device that Windows by itself, by default, normally hides simply because they don't have much relevance and there's no configuration, there's nothing you can do with it anyway. And that would be all these non-plug-and-play drivers, for example. So for example, whatever this thing is, that involves a driver that's not really a plug-and-play driver. Many of these are, probably all of these in fact, are just hard-coded drivers that Microsoft themselves have made to cause Windows functionality to operate. And so very often these are also unsigned drivers. We'll talk more about signed drivers later on. But this is one of those things that it would show you, and that's how you can expose those if you want. The other thing that it would show you, besides non-plug-and-play drivers, would be any devices that used to be attached but are now detached. So for example, if I had a USB flash drive, which I sometimes plug in and sometimes that I don't. Well, right now it's not plugged in, so it doesn't show up here under disk drives. But if I were to plug it in and drivers were to install for it, then it would show up here if I still had it plugged in. On the other hand, if I were to remove it again, it would disappear again from the disk drives item. Now, if I wanted to show hidden devices, then that device might appear after all. Why would I want a device to appear in Device Manager, even if it was not plugged in? Very often that's what I need to do if I know in advance that I need to maintain a driver. For example, maybe that driver needs to be updated before I plug the device back in. Maybe the last time I plugged the device in, the driver wasn't very good, and so I got a blue screen of death, and the computer spontaneously rebooted. Well, I don't want to have to plug the device back in and hope that I can get to Device Manager to fix the problem before I get a blue screen again. So what I can do instead is to show the hidden device, probably remove it or update it, and then install the manufacturer's driver, and then hopefully I won't get a blue screen again. So that's just an example of very often why we want to view those hidden devices. Another key component of working with devices is the fact that you can use Device Manager to enable devices, disable devices, and uninstall devices. Let's go ahead and take a look at how we might work with something like that. So for example, here if I go ahead and take a look at this, and let me try to find something that I don't really use or care about. How about a floppy disk drive? I can't remember the last time I actually used a floppy disk drive. So with this thing, I probably could care less if it's operating or not, so it's a good item for me to disable right now if I wanted to. On the other hand, I wouldn't want to disable something like my processors. That might cause a real problem or throw a wrench in the works. So here what I do is, let's say that this particular device, and you can insert anything in here, floppy disk drive like we're looking at now, or some other device, some kind of a network card, or some kind of a storage controller, so whatever it is. If it's causing you a problem, very often you'll want to disable it. And one of the reasons why you want to do that is to confirm that it's actually this device. If I disable this device, and it's telling me it's going to stop functioning, you sure you want to do this? I'll say yes. If I disable this device, and then whatever problem I'm experiencing continues to happen, maybe I continue to get blue screens, or maybe I continue to get systems locked up, well, it might not be this device that I thought was the problem after all. I might have to try something else to disable or to work with. If I realize that I really want this back, then I can right-click here, and then I can choose to enable that device instead. Likewise, if I decide that I want to uninstall it, maybe I suspect that I'm having some driver problems with this particular driver. Maybe it's not a signed driver, for example. Then I might just uninstall it. Okay, and I can just click OK here then. Now, once again, if it turns out that, oops, that wasn't the problem after all, and I need that back now, then if it's a plug-and-play device that's currently attached to the machine, then you should be able to also scan for hardware changes. And most devices through plug-and-play, and you can see it being detected right there, and there it goes, will automatically be redetected by plug-and-play, and will reinstall themselves quite nicely. Other things you can do with Device Manager is driver management. In fact, that's probably the majority of what you'll do with Device Manager. It used to be that you could assign or move around the resources that devices were using in Device Manager. For example, if something was using interrupt request 7, you could move it to interrupt request 8 or 9 or something like that if you wanted to. Well, most of the time you can't do that anymore because ACPI itself actually locks out most of that. So it really truly is now, most of the time, Windows that administers that. Even if you're a high-level administrator, frequently you have no control over that anymore, which is fine for the most part now because most of the time things work pretty well. Anyway, when you work with drivers, though, these are some things that we still do need to administer from time to time. One thing you can do with Device Manager is to just view the drivers. You might not know the name of the driver that's used to control a specific device, so you might need to find that out and find out the name of the file. That's very useful because you can then examine that file. You might be able to do a Google search for it or something like that to see if it's causing problems for other folks. So that might help you to track down some problems that you are experiencing. You can also update your drivers. This is something that we also do pretty frequently, and sometimes this can take place automatically, especially if you use something like Windows Server Update Services. And again, we'll talk more about updates at a later point in time, but if you approve centrally maybe a network card driver that has been updated and is available on Windows Update, well, a WSUS server will download that update to the WSUS server, and then if you have a lot of clients in your environment that use that exact same network card, then it can distribute that new driver to all of those clients automatically over a staged period of time, and then they'll apply it, and that's pretty much it. It's probably even transparent to the user. They may never even know that those drivers have been updated. Otherwise, you might have to do something like this manually within Device Manager. So let's say here that, let me try to find a good device. We were talking about network adapters. I'll just use one of these. Oh, it's kind of cluttered here. Let me turn off my hidden devices so we don't have quite so much clutter. And now when I take a look at this item, I might say I need to update the driver software. And then what it can do is it can search automatically for updated driver software. And what it does here is first it looks in my staged drivers. And that would be drivers that I already have on my computer, and it will look for those, and it will compare them against the driver that's currently being used. Drivers do have versioning in them, so it should be able to identify whether or not the driver that it's found is more recent than the one that I'm currently using. And generally speaking, it will attempt to use the more current or the most recent driver. Okay, so that's what it'll do. If it doesn't find it as a staged driver, there's also driver caches that exist on the system, and it can look inside of there to see if there's a driver for this device. And again, it'll try to use it there. After that, it uses removable media, such as CD-ROMs, thumb drives, those sorts of things to look for drivers as well. And what it really does is it scans for INF files. INF files have hardware IDs that match up with hardware IDs on the actual physical device that you're trying to install or update. Because each manufacturer has a unique identifier, and then within each manufacturer, they also have unique identifiers to identify that specific model of whatever device it is that they're working with. And when the INF file matches that up, then it will also have information in the INF as to what files are needed to install the drivers for that. The actual core driver itself normally ends in an .sys extension. And so that's one of the files that for sure usually gets copied. However, there may also be other accompanying files. For example, if it's a signed driver, then it's also going to need a catalog file. I'll talk more about that a little bit later on here. Then the other thing it would do is if it can't find it there, then it can even go out to the internet, specifically Microsoft's Windows Update site, and it will again take the hardware ID out to the site, try to compare it against everything that Microsoft has available. If it finds a driver that's available on Microsoft's Windows Server Windows Update site, then it will download that to your computer and install it. And that's very often a good way to install drivers because Microsoft only uses signed drivers, which are substantially more stable than unsigned drivers. And then the other way I could install a driver to update it would be to browse my computer for the driver software. Now, why would I want to do that if it's already going to browse my computer for the driver anyway? Well, what could happen here is I wouldn't want it to somehow actually go out to Windows Update site to download a driver when I know that the one I have in the CD-ROM is going to be better anyway, or maybe it's the one directly from the manufacturer. As a general rule, even though there might be a more up-to-date driver on Microsoft's Windows Update site, if I have one that I've recently downloaded from the manufacturer, I'll usually prefer that one, especially if it's signed, because that manufacturer will probably also include additional features in that driver that the driver on Windows Update site may not include. Very often, the Microsoft version of the drivers include basic functionality, but not a lot of the fancy features. For example, if it's a multifunction printer, it may allow you to print to it using the Microsoft driver. But if I also want to scan and fax, then I'm probably going to have to use not only drivers from the manufacturer, but also probably accompanying software from the manufacturer that allows me to do those things. So that's how we can update our drivers. I may also want to use Device Manager to uninstall a driver, especially if it's giving me some kind of problems and so forth. I'll talk more about that here in a little while. Also, if I have resource conflicts, let's go ahead and take a look at resources within Device Manager. Let's just go back to this network card again, for example. If I double-click on that and go to the Resources tab, actually, let me go back here. Notice, first of all, that it says the device is working properly. Sometimes if it's got a conflict or the driver is not properly loading, it will give you a device status there that tells you about that problem. So it'll tell you that there's a resource conflict or something like this. Now, in current versions of Windows, mostly since, I think XP, and on through Vista and now Windows 7, I haven't had a resource conflict. It may have been 10 years since I've had a resource conflict. And that's very often because devices nowadays are actually pretty well built, the drivers work pretty well, and the resources are mostly controlled by ACPI. The time when you're going to not have resources controlled by ACPI is if you install legacy devices. If you do those, then very often you adjust the resources that they attempt to require by using some kind of a software interface for that device, or by using jumpers on those devices. Very often, for example, that would have been the case with internal modems. Very often you would have to select which serial port they needed, and that might be done by using a set of jumpers or dip switches on the modem itself. And then you would also have to identify sometimes which interrupt request it needed. So anyway, here we take a look at this. What's it using? Interrupt request 5. Now, if it was not an ACPI device, and it did not use current plug-and-play standards, this checkbox right here might have been cleared. I don't think I have any devices right now that let me clear this. I was going to try to demonstrate this, but you just really can't anymore. Everything's hard-coded and controlled by ACPI nowadays. But if it was an older device, once again, I might be able to clear that item if ACPI recognized it as a legacy device. Then I could click on Change Setting, and it would let me pick from a list of interrupt requests or memory ranges or I/O and all those sorts of things. Okay, so that's how you very often would handle those conflicts between drivers, which is what's stated in the exam objective. But once again, that's really a little bit, probably not very well stated, because drivers themselves very seldomly have conflicts between themselves. Usually it's the resources that the driver requests that have the conflicts. While we're here, let me take a quick tangent and take a look at a few of the other things we see here. For example, on the Details item, notice that we see a device description. This is the default property that you'll usually see. However, it might be very useful to further identify things about these devices. Maybe, for example, I want to identify the exact hardware ID. Now, it's a little bit beyond our scope, but one reason why I might want to do that is because I can use the hardware ID to prevent certain devices from being installed, and in corporations, very often I might do that. So, for example, maybe I don't want a class of device to be installed, such as USB flash drives. If I'm in a classified or secure area, I don't want people to plug those devices in, copy data to them, and potentially walk out of the building with them. That could be a security breach. So we could disable those devices using a group policy object, but in order to do that, I would have to know its hardware ID. So I could select hardware ID right here, and then the most specific identifier for this device appears right up here at the top. Down here towards the bottom, this is more of a generic description for any device from this manufacturer in this class. And so if I wanted to prevent all devices of this type in this class, then I would select that item. I can right-click here to choose Copy, and then I would work with a group policy object, for example, to paste in that identifier and prevent it from being installed. And then people could not install those devices. There's some holes in that, because if the driver already exists on the computer, they could still install it anyway. So it was not that great, at least initially when Windows Vista first came out. But now there are better methods for being able to control those things. So that's been tightened down a little bit. And then returning here, there's also the driver itself. Now, what I want to see here is Microsoft Windows is the digital signer. this is going to be an indication that it's a stable driver. I'll talk more about signing in a little while. The driver details, if I want to know the actual files that are being used, remember I said earlier, normally those are going to be SYS files. And it tells me right here where the file is located for that. And if you look at the path there, that is the driver's path for any devices that I have installed. There's also other areas where drivers are kind of in a waiting area, so that I might not have installed the devices that those drivers correspond to quite yet. But if I plug one in and plug and play detects it, then it can pull it out of that location, extract the driver, and then it copies it into the driver's folder. And then here I just thought I'd go ahead and open up the location of that. This is the driver store. It's a Windows System 32 driver store file repository. That's where all of these things are. And if you click on that, you'll see that there's the driver file itself. There's the INF file I mentioned earlier. And if I drag this down so you can see it a little bit better, this is where it will again identify. I don't know how that popped up, so let me close that thing. This is where it will identify various items about that particular driver. Okay, what file it needs and so forth. All right. So that's part of the idea that we see there in where those files are located. You don't need to memorize that for the exam, that is, for the 70-680 exam, but that's just information. Also, this is where we can also update the driver. Once we have updated the driver, let's say I updated it and I was able to find the appropriate driver and everything, and then what happens is every time I try to use that device, my system locks up. Well, that's no good. That's probably an indication that the driver, since that's the last thing I changed on the computer, is causing the problem. Well, if that's the case, and if I've updated this driver in the past, then I will have the rollback driver item available, and it will allow me to completely go back to the previous driver that we were using. It doesn't actually delete or overwrite the old one. It actually retains the old copy of it, and it puts it in a compressed location, and then it allows me to retrieve it from that location if I need to by using the rollback driver. You can also disable and uninstall, which we discussed earlier as well. Now, some devices, such as video cards, network cards, and devices of other types, may have an additional tab or two here. Like on this network card, it says Advanced, and this allows me to control different things related to the network card. For example, the receive buffers. I might want to change the size of the receive buffers because maybe I have a router or a switch that doesn't like the way these are sized, or maybe they're being fragmented on the network, and I might want to make them bigger or smaller. Bigger for more efficiency, but smaller if they're getting broken up because the router or the intermediary device is not able to handle packets that big, and it has to keep manually breaking them up in order to transmit the packets. So I might do something like that, for example. I'm not going to do that now. I'm just telling you that in this interface, you may have an advanced or some other kind of a tab there that also allows you to more specifically work with that particular device. Now, I talked to you about signed drivers before here a little bit, and we alluded to those. Let's talk about what these really are. Before signed drivers, Microsoft estimated that around 90% of the blue screen of death error messages that users would receive were due to unsigned drivers. These are drivers that are unstable, and because many times these drivers might try to directly access the hardware, or perhaps they're just not very well written, then they will cause catastrophic failures for the entire operating system. And very often what happens with the blue screen of death is that you may briefly see up in the upper, I think it's usually the upper left part of the screen, a message relating to what device driver was causing the problem. But sometimes that message is only up there for a brief moment, and then it goes away and the computer reboots. So sometimes it's difficult to identify exactly which device driver was causing the problem. It's just a frustration. Okay, so the blue screen of death was a big deal, and Microsoft took a lot of heat because Windows seemed to give the blue screen of death quite often for a lot of folks. Fact of the matter is, it was often not Microsoft's fault. It was the manufacturers who were writing buggy drivers that were not very good. So that's when they introduced Window Hardware Quality Labs. There's also an engineering division among Microsoft that can also sign these, but most of the time for any products that you can buy off the shelf, it's going to use a WHQL, or Windows Hardware Quality Labs, signature that's affixed to the driver. And what they'll do is they'll use a sign tool utility to be able to do that. So what happens here, by the way, and it costs the manufacturer of the device thousands of dollars because they have to foot the bill for testing that driver, and they also have to send in hardware for it to be tested on and everything like this. It's quite an elaborate process, which I read about some years ago online from Microsoft. But anyway, once Microsoft has set it through its paces, and if they find out that it doesn't cause the system to lock up or blue screen or cause performance problems or have things such as memory leaks, which is where a device may use certain portions of memory, and when they're done using them, they're supposed to give that memory back to the operating system for it to be reused. Well, if it doesn't do that and it just holds on to it indefinitely, that's called a memory leak, because it will continue to use more and more memory that never gets released. Anyway, if it's not having any of those kinds of problems, Microsoft will sign that driver. Let me show you an example of a signature. Here we have a driver that was signed, and it uses a security catalog. And this catalog here, when we take a look at this, is where the actual signature information appears. You see, all of the information that we see here, the thumbprint algorithm, all these sorts of things, actually are generated from the fact that it has a certificate associated with it. If you want to view the signature itself, you can do that here as well. We notice that this particular driver relates to DiskKeeper, meaning that I can use the DiskKeeper product on this computer without any concern that the driver that it uses will blue screen me or something like that. And then you can see here that it used a VeriSign timestamping services signer, and I can view the certificate itself as well to make sure that the certificate has not been revoked or have some other kind of a problem. And if I look at the certification path, I see that everything is fine. By the way, the reason why I was able to install this device and driver without getting any problems, and you didn't see me install it, I'm just telling you that there were no problems with this, is because it goes up the chain and it confirms that the issuer of this certificate is indeed a good certificate that is in my trusted root certification authority's store on my local computer. That's way beyond our current objective and beyond what we need to know for the exam purposes, but I'm just telling you that so that you know something more about these certificates. There's a whole chain that goes on, and this chain of trust must not be broken. So, for example, if there was an issuance later on that says that this particular CA got compromised and its certificate got revoked, then any certificates that were issued by the CA, such as this one, would then be bad and they would all have to be reissued. Okay. So anyway, it's signed, it's got a good certificate, therefore Windows knows that this is a trustworthy driver, and I should be able to continue on any installation there without seeing any messages or pop-ups or anything like that, prompting me for any other kind of permission relating to its signing. And so again, those devices that are signed drivers are thoroughly tested, and the catalog file, the CAT file, is signed using the Sign Tool utility. Now, very often, if you have troubles with your devices, it's going to relate to the drivers themselves. So, in order to troubleshoot the drivers, you need to first of all identify the problem. Usually, you can do that within Device Manager, because it will give you a yellow symbol with an exclamation point on it, and it will often give you a message there right on the General tab saying that the driver could not load, or a suitable driver could not be found, or it's an unknown device, or something of this nature. Anything that's an unknown device, that's simply another way of saying that there was no driver found for it. Because if a driver was found, then it would be a known device. So another symptom of a problem device might simply be that it doesn't work. So that's obvious enough. Now, another thing you want to look for in identifying problems is to check for unsigned drivers. Very often those are still going to cause problems, especially if it's something that causes the system to either lock up, which means that the mouse won't move, there's no input response from any I/O, such as the keyboard or mouse, and the only thing you can do is to reset the computer or power off the computer. So that's another indication of an unsigned driver, plus the blue screens that we talked about earlier. Now here's an official answer from Microsoft, by the way. For 32-bit OSs, they say that it is still allowed and permissible to install an unsigned driver. But for 64-bit operating systems like Windows 7 64-bit edition, it is not okay. In fact, Microsoft says it's not even possible to install an unsigned 64-bit driver unless you restart the computer, press F8 during the startup, and then choose a special startup option that allows you to install unsigned drivers temporarily. Well, in my experience, I've installed several 64-bit drivers that were not signed without going through that whole process. Just from within Windows, installed those unsigned drivers. I don't like to do it because unsigned drivers are less stable, and I don't trust them nearly as much. But for some devices that I have, that's all I've got is unsigned ones. So I know that it's true, but your official answer is you cannot do it. Okay, just be aware of that. Now, how do you identify and check for unsigned drivers? You can use DXDiag, Signature Verifier, or Driver Query. Let's go ahead and take a look at those tools. So, for example, if I wanted to identify unsigned drivers using DXDiag, I would press or I'd go to a command prompt here or a run line and run dxdiag, you can see here that it checks for Windows Hardware Quality Lab digital signatures, and it also gives you core information about the computer that you're using. Sometimes this can be useful information. There's also a 64-bit edition of dxdiag as well, and I can run that also if I want to. So anyway, once we run this tool, let me bring this in here a little bit further. This is the 64-bit edition. Then we can identify key components of this system. And by the way, since I'm running a 64-bit edition of Windows, then I do actually need to run the 64-bit edition of this tool, because otherwise, if I go to something like display here, then it will not see the appropriate driver, and it won't give me the right information. So here it says Windows Hardware Quality logo is yes. If it said no, then I would need to go to the manufacturer's website and hopefully get a signed driver. By the way, with display adapters as well as other things such as multifunction devices, certain cameras, things that are a little bit more elaborate devices besides just keyboard, mouse, simple things like that, you may need to actually run a setup utility that includes not only the drivers, but also accompanying software that helps to control that device. Okay, just be aware of that. Also, very often, especially with multifunction devices, you should install that software and the drivers first before you plug in the device. Because what will very often happen is if you plug it in first, then it will use default Windows drivers, which may not include all the functionality that you want. So anyway, here we have no problems with unsigned drivers. Here again, this one's Windows Hardware Quality Labs. This one is too. So we don't really see any issues here with any of these particular devices. And then here it will show me the various I/O devices that we have available as well. So that's the dxdiag tool. Now let's go ahead and take a look at the next one. And for this one, we're going to run the sigverif tool. Oops, didn't type the whole thing. F on the end. And what this does is it just checks through your system, just another way of checking through, and it looks for any unsigned drivers. This is going to actually be more thorough than dxdiag, because this will check every device and driver, whereas dxdiag really only checks things that are related to the functionality of dxdiag. But then you can also click, of course, advanced here and save it to a log file if you wanted to examine it later on. But I'm just going to go ahead and click on start. This will take a few moments to run, and then it'll identify any unsigned drivers. Now then, what did it find? Well, a single driver that is not installed. This is actually a Windows system driver, so it doesn't really matter in this case, because again, some drivers Microsoft does not sign, but that's because it would be a little bit redundant. It came from Microsoft, and so that they apparently have confidence in it. The other thing you can do to look for signed drivers would be the driver query utility. I think I've got that right here somewhere. There it is. The driver query. And with this, I would do a driver query space /v for verbose, and then I want to output it to a file, a CSV type of a file, and I would use the arrow there to point to this file name that I wanted to send it out to. Now, this actually doesn't check for unsigned drivers, by the way, but it does give you a lot of other data about the drivers. So I'm going to go ahead and crack this thing open here, and we'll go to my temp directory where I saved the file, and you can see that it saves it as a CSV, which is readable by Excel. And so this will just give me a lot of information. Is the driver started and loaded? Is the status okay? All kinds of things here. What's the path for it? But this doesn't give me all of the data, such as whether or not the device is signed. In order to do something like that, number one, you can't use the verbose mode, but you could still go ahead and check to see whether or not the driver is signed by using a different query. So here, for example, I would do the same thing, only I would do /si for signed, and I'm looking for any of those drivers that are not signed. So I'm going to press enter here again, let it do its thing, and then when it's done with that, I'm going to go back into this. Now we have a new file here called driver sign. When I double click to open this one up, then you can see here, let me equalize these columns out a little bit better. Then you can see now it tells us whether or not the driver is signed. And if you want to take a little bit more of a look and scroll this for only unsigned drivers, you can use the sort and filter options here in Excel, for example, and then I could do a filter or a custom sort. And then here, once I choose filter, then I'll say I only want to find, not all of these, but only false, meaning unsigned drivers. And then it would show me anything that's unsigned. And again, as you can see here, many of these are going to relate to just actual Microsoft products, although a couple of these are not, such as these VMware items. Oh, here's the other one, this Magic ISO SCSI host controller. That's not a signed driver, and that's one thing that I will frequently install. I use that on every machine I use, that allows me to connect to an ISO file instead of actually using a DVD. And in the interface, it makes it look as if it's actually a DVD when it's really not. So, for example, this item right here, that's not a physical DVD drive. I'm on a laptop. I don't have 2 DVDs. This is actually just going to be it's using Magic ISO to simulate one of those items. Okay. So anyway, that's the kind of idea there, is you can identify what has not been signed here, and that might be useful information for you as well. Other items that you may be able to work with would be to update the driver. Okay, we showed you how to do that earlier in the interface of Device Manager. And then you can also roll back if the update either doesn't fix the problem or it might cause a worse problem. Maybe it causes you a blue screen to update that driver. So you can roll that back. And by the way, if it causes such a severe problem that you can't even possibly boot into Windows anymore, then you might consider booting to safe mode and trying to update, or rather to roll back that driver. Or alternatively, you can also choose the last known good configuration, which is a boot option that you'll see from the F8 menu. And that would then also roll back that driver for you as well. Another thing you might try consider doing is to uninstall the Microsoft version of a driver, especially if it's a driver that does not give you all of the functionality that you expect out of that device. Because again, it's kind of a generic driver that just gives you base functionality. And if that's the case, then you would uninstall the Microsoft edition and then install the manufacturer's clean. You could also use the update process to update to the manufacturer's version of the driver, but I don't always recommend that. It seems to work much cleaner and better if you just completely uninstall and then reinstall the manufacturer's. You might also install the manufacturer's software, again, just to get better functionality of it, such as with this particular Wacom drawing pad that we're using. You see, you can't see it from where you are, but I'm using a Wacom drawing pad. That's what I do to get all my scribbles and to write on these whiteboards and everything like that. Well, what happened was when I first came over to this laptop to use that, it installed the Microsoft drivers. And all it really gave me was this right here, the USB input device. It did not give me any pressure sensitivity or any of the other features that I would get out of this device normally when I'm using Photoshop to draw these whiteboards. But by installing the manufacturer's device driver and accompanying little applications, it gives me these additional items that would then give me additional functionality with this particular software, and it seems to work a lot better. So that's just an example for you of using the manufacturers as opposed to Microsoft's drivers. Another thing you might need to do is to install legacy devices. Now, I haven't had to do this for a long time, with one exception a while back, where I had a client that insisted that I install some old modem. I think it was back from like the mid-90s or something like that. And it was not a plug-and-play modem. It used jumpers and dip switches. Well, I told them I can buy you a brand new one for probably $15. Well, no, they insisted that I installed that one. It actually cost them more in my hourly rate to install that old crusty one than it would have if I bought them a brand new one that used plug and play. But anyway, if you install something old, you might need to go up here and choose Add Legacy Hardware. And if you don't, the device might still work. But if you do, then you can further work with that device here in Device Manager and adjust the resources that it's using, possibly from here, or work with other devices there. Oops, I clicked next and I didn't mean to. Let me try that again. I'm going to install the hardware from a device list that I manually select. And then you can just choose, whatever it is, an imaging device. I don't know. And then I'll just install whatever this Lexmark item is, and next, and finish. Okay. Now, once I've done that, I'll then have that device installed, and you'll see it here. There it is, in fact. Okay, this Lexmark device. Remember, we have the exclamation point there? It said the device cannot start. Remember, I told you that you might see devices of this nature. In this case, the device is not starting because I don't actually have it attached. It's not actually installed. So that's an example of that sort of a message. But anyway, I only show you that so that you can identify how to install any legacy devices, although hopefully you never have to do that ever again. Here I'll go ahead and just uninstall it, and I would do this the same for plug-and-play and legacy devices either way, and that's pretty much all there is to that. In this nugget, we talked about configuring devices. One of the key things we talked about there was Device Manager, which really addresses virtually all of the exam objectives relating to devices, because that's where you configure your devices. We also talked about signed drivers, the importance of signed drivers. Remember, it's primarily that they're more stable, and that for the official answer from Microsoft, you cannot install unsigned drivers in 64-bit editions of Windows. And then we also, of course, took a look at troubleshooting, and that's a big part of what Device Manager is used for. Well, I hope this has been informative for you, and I'd like to thank you for viewing.